Math. Why are we talking about letters? It's like, Sesame Street or something. But the letter E is actually very important. The letter E, well, let me first get through some of the things we're talking about here. We'll go ahead and use our mouse function. Oops, off the mouse function. There we go. And let's talk about some of the things we're doing with the letter E. So, applications, oops, I've gone too far. There we go. Applications, we use this in biology to talk about the growth of bacterial populations or the decay of other things such as fossils and whatnot. Camera phones, I think there's an example in your textbook about camera phones, and also with termite population. Now, the only real vocabulary for this example, for this lesson, is E, okay? And E is called the natural base E, or we also call it the Euler number. Leonard Euler is a very famous mathematician. You have actually already dealt with several things that Euler is famous for, besides just the Euler number. Function notation, when you say f of x, all right? He was one of the first people to actually popularize this notation. When you're writing a graphical notation and you say this is a function in relation to the argument x, right? Using this notation and putting in whatever you want to substitute for x into that spot, he was one of the first to pioneer it. Also, using the letter I to represent imaginary numbers. Now, he didn't discover imaginary numbers, but he is one of the ones to first start using the letter I. He wasn't the first to use pi to represent the ratio of a circle's circumference to its diameter, but he did popularize it in the 18th century. One thing I want to make clear about the Euler number is that E is a number. Like pi, it has a set value, all right? And on your calculator, in order to see it, you'll need to hit Shift, and then you'll see e to the x power, all right? So if you want to find the value of e, all right, hit e to the first, hit enter, Shift e to the, and then 1, and then enter, and it will give you the value. It is approximately 2.718 ... All right, it goes on forever like pi, but that's approximately the value of it. We'll want to know that for later purposes. All right, so let's go ahead and take a look at some applications of the Euler number. First example is just simplifying some expressions using the Euler number. We're not actually going to solve it per se, but it would be nice and easy to do so. So when simplifying expressions, again, same rules as exponents have always applied. We are dealing with, I don't like the green, I'm going to try and change this. My calibration appears to be off. Come on. Give me the blue. There we go. There we go. I think that's working. All right, so the bases appear to be the same. All right, so all we have to do is add the exponents. When you multiply bases, multiply powers, bases are the same, add the exponents. And then, using our calculator, we could type that in. We don't necessarily need to do that when we're simplifying the exponents, but it's always good to kind of see what that would look like as an answer. So type it into your calculator, and you get a value of approximately 22,026.4657. So let's round that to 0.47. All right, from now on out, I'm not actually going to solve the expression. I'm just going to simplify it to simplest terms of e to the 10th power or whatever the answer is. All right, so we'll take a look at example B. We have powers in the numerator and the denominator, so we know we're going to subtract the exponents. So 8 minus 2 is 6, and then 21 over 7 can both be divided by 7, making it 3 over 1. So of course this simplifies to just 3 times e to the 6th power. All right, for example C, we have parentheses and we have an exponent outside the parentheses. That means we need to distribute that exponent to both parts of the parentheses. So we have -2 to the third power times e to the x to the third power. All right, so -2 to the third power is equal to -8, and e to the x power to the third power would be e to the 3x. Remember, you multiply your exponents when you have a power of a power. Okay, so go ahead and take a look at some of our examples. And take a moment to visualize these, not visualize, actually once you to solve them, go ahead and solve out these expressions. Pause, and in about 10 seconds, I'm going to go ahead and write the answers. So go ahead and pause so that you have time to solve the problem. Okay, hopefully you've had time to write your answers. I'm going to go ahead and give you the answers. All right, so e to the 9th, 28, e to the 3rd, 6, e, I'm going to rewrite that one, 6e to the 5th, and 121 e to the -6x. If you have any questions on these problems, make sure you circle them and bring them up in class. Okay. I'm actually going to go ahead and stop this lecture, this part of the lecture now, and we'll come back to the rest of the examples. I think that gives us a good introduction to talk about the Euler number, and then I'll continue on with the next video.